What stack are you using for building AI applications? Well, these three amazing projects use PowerSync as the data layer that underpins some seriously solid AI-powered workflows. These are the top 3 winners of the PowerSync AI Hackathon, and we are going to take a quick look at what makes these projects special, and more importantly, what you can learn from them about building better AI applications. This is a system for point-of-sale and retail operations for small stores. It combines checkout, inventory, purchases, customers, cash flow, expenses, reporting, team access, and on-device sync, all in one workspace. And the first thing that stands out is just how fast it feels. No broken workflow, no waiting around, no loading spinner killing the flow. But the real standout is the AI integration. This isn't just a chatbot layered on top of the product. The assistant can actually perform real store operations like updating stock, creating sales, and managing records directly inside the system. It can use both cloud models and locally hosted models, which means you can use the assistant even when offline, keep working, and have those changes sync back to the cloud and other devices as soon as you reconnect. It also uses Tari for the cross-platform packaging, so it can run as a native app as well as on the web. And there's a small Rust backend handling calls to OpenRouter and Olama for the built-in assistant. This is a really strong example of building an AI product that stays useful in the real world, not just in perfect network conditions, and of how PowerSync makes that kind of architecture much easier to pull off. This is a workout assistant app that connects to a Garmin watch to collect metrics. The backend receives webhook notifications from Garmin Cloud, stores them in a database, and then syncs that data across both a web application and a mobile app. PowerSync is the data backbone for the whole thing, and on top of that, there's a wide range of AI features: chatting with a coach, generating notes for workouts and journals, transforming data from natural language, creating weekly digests, and building training plans, all grounded in real workout data and training science. What makes this especially strong is that AI isn't just reacting to raw data. It's grounded in real computed training metrics first, and then uses AI to interpret that data, generate coaching, and personalize plans in a way that feels much more credible. I also really like that this project has separate mobile and web applications designed for their actual use cases. The mobile app uses Expo, and the web app uses Tanstack Start. The web app also uses TanstackDB's incremental live queries, which gives it a really nice performance boost on some queries. The coach is bilingual, so it can help in both English and Norwegian. This is a great example of what happens when you can sync data seamlessly across apps and layer AI on top of that foundation for everything from background processing to personalized plans to grounded real-time assistance. This is a local-first observability and analytics tool. The idea is that apps collect and store analytics locally, and then PowerSync syncs that data into this analytics console. One of the most impressive parts of this project is that it uses a custom PowerSync DuckDB integration for the console app instead of the regular SQLite, because DuckDB is a much better fit for analytics queries. The AI agent inside the console can inspect the schema, generate queries, and run them directly against the local database. And instead of just dumping results as text, it can also render a custom dashboard from those queries. So again, PowerSync is the backbone moving data from the user-facing apps into the analytics console. But this project goes a step further by hooking into the protocol layer and swapping in a local database that is much better suited for this exact use case. It also includes a React Native reference app that shows how telemetry is captured and synced. The reference app captures AI-specific telemetry like routing decisions, fallback reasons, latency, token usage, and even cost, which is exactly the kind of data that you would need if you want to understand how an AI system is actually behaving in production. This reference app uses hybrid inference, automatically switching between the local models for simpler tasks and cloud models for the more complex ones. This project shows not just how to build AI-powered apps with PowerSync, but how to capture analytics and telemetry from those apps so that you can actually understand what happened. That means less guesswork, less mystery, and better decisions based on real data. Huge shout out to the people who built these projects and won prizes at the PowerSync AI Hackathon. All three of these projects show why apps built with PowerSync can do so much more than apps built with traditional APIs alone. You get instant local reads, real-time sync, and offline support out of the box without having to stitch together a pile of infrastructure and glue code yourself. Hopefully this gives you some inspiration for your own AI apps, and if you want to go even further, stay tuned for the next video. Or just check out powersync.com and start building already.